Okay, good afternoon everyone and welcome. My name is Shadrach Atebe, and today we are going to spend the next 10 minutes looking at a really practical networking tool called pathping. So before we start, let me quickly take attendance. I can see your names. I can see your names in the participant list. Thank you for joining. So I'll start with Joseph Meiwo. Are you present?
Yes, present, sir.
We have Dorcas. Dorcas. Alton.
Present.
Present.
Emmanuel.
Present.
And we have Sharon. Sharon.
Present.
Lawrence Makori. Lawrence Makori. Okay. James Kilonzi.
Present, sir.
Grace.
Present.
Eileen.
Present.
Thank you very much. At this point, I'd like to share my screen so that I'd like to share my slides so that we can learn on what to expect from today's lesson. Can you guys see my screen? Can you see my screen?
Yes.
Okay, so by the end of this session, you'll be able to do 3 things. By the end of this session, you'll be able to do 3 things, and one of it is you'll define what pathping is and the 2 key things it measures. You will also interpret pathping outputs and identify where packet loss occurs. And lastly, you'll be able to apply troubleshooting action based on pathping results. So let's also keep in mind basic online safety by keeping your settings on safe browsing. And just to let you know, we won't be accessing any restricted systems today. So let's get into it. Before I show you anything, I want to hear from you guys. I'd like to put a quick question on our poll so that we can be able to chat a little bit. So I'd like to see you guys participate in that chat. Have you ever used ping or pathping before? Have you ever used ping or pathping before? I'd like you to answer with the yes or no. Have you ever used ping or pathping before?
Yes.
If your answer is yes, you can type it there. Yes, and if yes, I'd like you to tell me where you used it. Yes, thank you, Emmanuel. You've used it before. Alton, yes. Joseph, yes. Thank you, guys. So, for those who've used ping before, pathping is going to feel familiar but more powerful. For those who haven't, don't worry. I'll walk you through it step by step. So here is the question we are answering today. If a user tells you my internet is slow, how do you find out exactly where the problem is? If a user tells you my internet is slow, how do you find out exactly where the problem is? So that's what pathping helps do. So let me share my slides again. Okay, so each of you can see my screen, right? So think of pathping like sending a letter and tracking every post office it passes through. It tells you which post office lost or delayed your letter, right? So when we have ping will help us test if a destination is reachable. It will also give us overall round trip time. And we have tracer. Tracers shows every router or hop along the path to the destination. It shows us where the traffic is passing through or the internet is going through. Then we have the path ping now, which combines both tracers and ping to show each hop and measure packet loss at every hop. So path ping actually combines these two tools, as you may already know. Ping, which tests if destination is reachable, and tracer shows the routes your data takes. So path ping does both at once, and it tells you the percentage of data loss at each stop along the way. So I'd like to run it live, and those who are seated next to their machines, you can open your commands. If you open your command, has any one of you been able to open their command? For those who are not able to, you can, I'm sharing my screen and you can follow it with me. So if you have opened command prompt, I'd like you to type path ping google.com and press enter. So when you press enter, you are now running the command. So you will let it process the information. And while that's running, notice it's now testing. It's now testing each hop multiple times. So that's how it calculates packet loss percentage, not just a single ping. So here is our results. As you can see, it has written tracing route to google.com over a maximum of 30 hops. So the first result shows where I'm connected to, and as you can see the outputs down the left, we have the hop number. The hop number is here. I hope you are seeing, and that's each router. Our data is passed through. So all these are routers within I'm connected to the Gishaga Hall network. So and as you can see, these are all the hotspots through which our routers are connected. As you can see the router, the hop number here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, is still computing. So each router our data passes through is being displayed on the command. And so here in the middle, we can see some of the let me show you. So in the middle, this one is packet loss. If you can see, actually, let it finish calculating, so that you can see the percentages of the data that has been lost as it goes through the calculations. So sometimes it's fast, sometimes it can take, sometimes depending on the number of hops or routers within your network. So at this point, let's get back to it later and continue exploring our pathing process. So here is the procedure of how to run your pathing. You open the command prompt, press Windows, Asal, then type CMD and press enter. Then you type the pathing command. You will see two sections, section A and the section B, as we have seen in our command prompt. So and in this case, this is how you read the pathing output. So like in our CMD, let me show you something. I hope you guys are able to see my screen. So what each column means? We have the first column which shows hops. We have this column here which shows the hop number. So each router your data passes through on its way to the destination, the hops. And then we have packet loss. In this current display, it's here to compute the statistics and provide us the total packet loss. Then we have the round trip time, how long in milliseconds it took. So currently the length in time is 225 seconds, but it is still processing the information. As you can see, it's computing the statistics. So while at that, it's I'd like you to practice it at your own time, and due to time, I don't think that we'll be able to do this, but you can come together in groups of 2 after this lesson and try out depending on the network you are connected to. So a quick check, and I'd like you to type your answer in the Teams chat. A user complains the internet is slow, but ping shows the destination is reachable. Which tool would you give more information about where the problem is? Are you able to see my screen? So there's a question here. A user complains the internet is slow, but ping shows the destination is reachable. Which tool would you give more information about where the problem is? A, we have ping again with a different IP. B, we have path ping. C, restart the computer. And then D, check the browser settings. Which is the most likely? Joseph? Yes?
Path ping.
Yes. Why path ping? Masix, why path ping? Why path ping and not checking the browser settings or restarting the computer?
Okay, I think path ping.
Yes.
Path ping will run the whole network diagnostic.
Yes.
And it will combine all the functionalities of the other commands such as ping and traceat.
Yes.
And it will also trace the route packets to the destination and clearly identify where the packet loss occurred.
Yes, thank you very much for all your answers. They are good answers. And as we have learned, path ping combines the 2 tools, the hop and traceat, to ensure that it diagnoses your network and finds where the exact problem is. So path ping would be the right choice. And here we have our results from what we ran. So I'd like to explain quickly what you are seeing on your screen before we conclude. On the screen we have we have our results here after running the test. We can see the minutes. Just bear with me for a minute. So the hop number, we have the hop number on our left side, the farthest end, hop number 1, 2, 3, 4, like that up to 6. And packet loss percentage, we have the packet loss percentage here. Like the first one we have 0%, the second one we have 0%, the third one 7%, the fourth one 7%, the fifth one 100%. And also, so this shows how many data packets were dropped at that hop. So at hop 5, we realized that 100% of the data packets were dropped. So here it says 0% is perfect, more than 10% is a problem. So if you have 0 to 9, it's perfect, but if you have 0, it's perfect. 0 to 10, it's 0 to 9 is a bit good or better, but more than 10% is a problem. So we see the fifth router here, the fifth hop, has 100% packet loss, which is a very big problem. And then there's the round trip time, the time how long in milliseconds it took to reach that hop and come back. So if you can check here, we have the time here, 6 milliseconds, 11 milliseconds, 10 milliseconds, 14 milliseconds. So it shows the time it took to reach the hop and come back with the results. So thank you guys for being in this class today, and I'd like to assign you some work so that you can handle it at your free time. But before that, I'd like to explain here. 0% is perfect results, so no packets dropped. This hop is healthy. 1 to 9% is acceptable. Minor loss could be normal network fluctuation. 100% is a problem. So as we saw, there's a big problem in hop 5. So your group task, as displayed here, you are going to discuss it in your group and identify which hop has a problem. How will you will know? As it is on my screen, kindly note it down and hand it over in our next class for further discussion. So thank you guys, and I wish you all the best until we meet again in our next lesson. That will be all for today.